Hi guys, how's it going? Long time no see. I can't really see your face because this is not live, but know that I miss you terribly. And so for these video lessons, it's going to be a lot like how I've done them in the past with my iPad. Woohoo! But now you can see my face too. What? That's awesome. Okay. So I know you miss my beautiful face, so you're welcome. I miss your faces too. So do me a favor and stop by the virtual live tutoring sessions based on your schedule that was sent out. I will be available on Microsoft Teams at the scheduled times for your class. So if you just want to pop in and say, hey, I can be like, hey. But obviously you definitely want to use those times for help with homework on Pearson that you're still going to have, or if you need help with, like if you have a question about the notes that we're about to take, or even if you need some help accessing anything online and you want me to like walk you through that, I can share my screen with you, or you can share your screen with me, and it can be a great time. Okay, so look at the schedule, stop by, say hi. But for now, we're going to take some notes on either our geometry notebook or OneNote. Okay. If you want to continue to use OneNote, I will continue to post the notes. I was playing around here with this one. So just remember, you want to go to, just pick a random class here. You want to go to Content Library here. Click on Unit 7, and you'll see I actually posted the blank copy of the notes for 7.4 that we're about to do. So then you can draw on that. You can click there, and now I can draw. It's not letting me draw. There we go. And now I can draw all over this. Yay, happy times, la la la. I should probably get rid of that in case anyone wants to use it. But remember, in order to draw on it, you have to move it to your name. So you would just click and drag under your class notes there. Okay? Oh, I don't want to do that. All right, well, I'm going to do it. Here you go, Alexi. You are welcome. You already got it there. Okay. Oh, darn it. I just moved it there indefinitely. Okay, never mind. We're going to move that back. Sorry, Alexi. Okay. So you want to, if you move yours there, it won't get rid of it. It'll stay there. Anyway, if you need help with OneNote, let me know. Otherwise, just take notes in your notebook. Okay. Remember, you want to take notes because, one, you can use those on the homework, you can use those on the quizzes you're going to have, and just in general, if you're just watching me, go through these notes here and write all this stuff down, that's not going to help solidify the understanding, right? You need to make sure you're going and taking notes while you're watching, because that helps you as you're writing. It's going to help stick into your brain. Okay, and you can also make notes. I need to ask her this question in our scheduled class time or whatever. Okay, so a couple things. We're not doing a quiz on 7-3, which was about the area of regular polygons. You still need to know how to do that. I hope you did the Pearson homework over that. If not, please get it done. But we will make sure we come back to that when we move on to surface area because it's necessary, but we're not quizzing over that. Our quiz will be over 7-4, surface area. And we're going to focus on 2 parts. So this video is only going to cover part 1. Okay, so I'm going to write that over here. This is part 1. And that's going to be prisms and cylinders. Okay, it's not going to let me do like an hour-long video. So, just kidding, it won't be an hour. But it's going to cut me off at 15 minutes or something like that. So I just thought it would be easier to split it into part 1 and part 2. That way you can kind of focus on that with the homework, because that's how the homework is split into part 1 and part 2. So yeah, we're going to focus on part 1 for now. Okay. Couple things before we really get into these calculations. By the way, you should have a calculator. Is classifying 3D figures. So now we're moving into 3 dimensions, and there are some things you should know. So we're going to focus right now on prisms and cylinders. So let's just make sure we understand all together the definition of a prism. Hopefully you know what it is, but if not, that's okay. It's here for you. A prism is a solid with 2 bases that are congruent and parallel. So that means, in this example, we have here's one base and here's the other base. You'll notice that they are like opposite each other, right? And they are congruent. And then how we name prisms is based on the base. So this figure is called a triangular prism because these bases are, you guessed it, triangles, right? That's a triangle and that's a triangle. One other important thing you should know is that the height of this prism, of any prism, is always the distance between the bases. So this would be the height of the prism. We'll come back to that more later. It's very, very important. Okay. A cylinder is just like a prism, but instead of having two bases that are polygons, which means it has like edges, oops, I'm sorry. The two bases are circles. That's it. Cylinders are super duper easy. You'll see. The height, just like a prism, is going to be the distance between the bases. So there's my height for that one. Okay. All right. So let's take a look at just a few of these. Where I'm skipping pyramid, cone for now. That's going to be a part 2 video, and sphere is a whole nother lesson. All right. So I want you to skip down to number 7 here. Really make sure you understand that one there. So in order to name this type of prism, you need to figure out what the bases are. But common mistake is saying, this is the base. Nope, that is not the base, my dears. The bases, because there are 2 of them in prisms, is going to be this guy here. Ooh. And let's do another color. This guy back here. Okay. Those are my bases. And if you mess that part up, then the whole formula is going to be wrong when we get to the formula part. So this is one base, and this is another base. The reason I know that those are the bases and it's not that one at the bottom is because they have to be congruent as well as parallel. So even though the bottom and the top are parallel, they're not congruent. That bottom one is bigger, the bigger rectangle than the top one, right? So the only congruent ones that are parallel are going to be those trapezoids. So think about this prism as like laying on its side, right? What that means though is the height is no longer how tall it is, right? The height is not going to be how tall it is. That's not what I want you to think of it as. The height of a prism is always the distance between the bases. The height is the distance between the bases. That's really, 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 really important when we start calculating these surface areas. So this would be the height of this prism. And then to name this prism, we have to name it by the shape of the bases, which you notice are trapezoids. So this is called a trapezoidal prism. Isn't geometry fun? Oh my gosh, you know what we forgot to do? Duh. Okay, let's stop what we're doing like we would in class and mentally prepare yourself. I really hope that you're like sitting in a room by yourself and you're about to yay math in a room by yourself, because that would make me really happy. Okay, because I'm about to do it. Okay. Ready? Yay math? Yay math. Okay, good job. You should come to the live sessions and we'll do like a yay math at the beginning. Okay? Okay. That was fun, but it's just not the same. Okay, let's move on. So now let's do some calculating, okay? Blah, 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 but you know what? I'm going to skip rectangular prisms or cubes. Okay, calculating the surface area of those is just calculating the area of all the faces and adding them up. But I don't want you to get confused and think that you have to like know these different formulas. By the way, you don't have to memorize any of these. At the end of this unit, I'll give you like a list of all of the formulas together, which is what I would have done anyway. So I don't want you to get confused. So we're just going to not look at these right now, because this next part where it says all other prisms, that can be applied to rectangular prisms. Okay, so we're just going to focus on General prisms, you can apply it to rectangular, triangular, hexagonal, trapezoidal, all of those. Okay, so we'll do one of these examples together. Let's start with number 4. Okay, these are the formulas that you need to know. So whenever you're doing your homework and your quizzes, make sure you have these formulas handy. For prisms, LA equals HP. What? LA is lateral area. Okay. And that's the area of the non-bases. We'll get to that in a second. And then you want to add in the area of the bases for the total surface area. So this next part, SA, stands for surface area. And then you have HP plus 2B. Whoa, that's a lot of random variables, right? So it's really important that you know all of these. Okay, you have to know what the variables mean. H is height of the prism. That means it is the distance between the bases, remember. P is perimeter of the base. Okay, not just any perimeter of the base. Okay, and then this one's really important. Capital B is the area of the base. Area of the base. Okay, so let's do number 4 together, and then if you're still confused, you can come and ask me questions, all right? This should make sense once we do this together, all right? So we want to find the surface area of each prism, starting with the lateral area. So lateral area is height of the prism times perimeter of the base. Okay. Height of the prism is the distance between the two bases. So you identify this as one base, and then this as the other base. So that means the height of the prism is 16. So 16. Now, perimeter of the base. Careful here. You want to make sure you're doing the perimeter from here to here to here. Perimeter means adding up all the sides, right? So we want to add up the side lengths of the base, okay? Now you see how I have a 15 here. Well, that's the same up here because those bases are congruent, right? And so to get that perimeter, let me do that off to the side here. You do 9 plus 12 plus 15. Quick question. If you had not known that last length 15 right here, guess what you can do to find it? Pythagorean theorem. What? That's crazy. Yes, you're still going to use that over and over again. So because this is a right triangle, we could have done Pythagorean theorem to find that that was 15. But they were so nice and they gave it to us. Okay? So now we'll on our handy dandy calculator, do our calculations, and we get that the perimeter is 36. So once we have that, we can now calculate, ooh, gross, the lateral area of this triangular prism. So 16 times 36 is 576. Okay, that is meters squared. But I'm not quite done. That's just the lateral area. So now we want to do the total surface area. Okay, so the surface area, let's do another color here, is HP plus 2 capital B. Okay, so you already know H and P. What we don't know is the capital B. So you want to identify what that is. First of all, it stands for area of the base, right? Like we said down here, area of the base. So what kind of base is this? Well, it's a triangle. Okay, so how do we find area of a triangle? We'll go back to 7-1, where we looked at all of those formulas, and the area of a triangle is half base times height, or base times height over 2. Now, carefully here, because this height is not the same as the other height. This stands for height of the triangle, and this is base of the triangle. So you kind of have to separate yourself, ignore the prism right now, the 3 dimensions, and focus just on your 2 dimensions. So I want to do 1/2 of 9 times 12. Why 9 times 12? Well, if you look at this right triangle here, this 9 represents the base, and this 12